Hello everyone, welcome to the fifth video in this series. We shall start with problem number 41. Which of the following phenomena is not evidence for an isospin symmetry between proton and neutron? Let us go over the options. Option A, charge symmetry of the strong interaction. It is an evidence. Charge independence of the strong interaction. It is also an evidence. Mass degeneracy between proton and neutron, it's also an evidence. So the correct answer would be C, anomalous magnetic moment of the neutron. So I have searched in Wikipedia and these are the values. The anomalous magnetic moment of proton is this 2.79 nuclear magneton, and for neutron it is minus 1.91 nuclear magneton. Problem 42. Which one of the following decay is permissible? So we will look at the Lipton numbers on both the sides. Let us consider option B. So the Lipton number on the left hand side is 0. Let us calculate the Lipton number in the right hand side. So beta minus has Lipton number plus 1, and the antineutrino it has the Lipton number minus 1. So this is equal to 0. So option B would be the correct answer. You can convince yourself that other options do not satisfy the Lipton number conservation. Problem 43. If P is the linear momentum and J is the angular momentum, the Poisson bracket P comma J dot n equals to what? So let us consider the ith component Pi Poisson bracket with J dot n. So the idea is to use the component notation. So Pi and J and J, and Einstein summation convention is implied. So we can take Nj out, and now we use the definition of J, that is epsilon J m n R m P n. So from there we can take epsilon J m n out and use the properties of Poisson bracket, that is R m Pi comma Pn plus Pi comma Rm, and Pm stays outside. So this is equal to 0 and this is equal to minus of delta I m. So thus we have minus Nj epsilon J m n delta I m P n. So use the delta function property to replace the index m by I. So that is equal to minus Nj epsilon J I n P n. And now you absorb this minus sign in the epsilon, that is epsilon I J n Nj P n, and this is exactly equal to n cross P and its ith component. Thus we have P as a vector Poisson bracket with J dot n is equal to n cross P. So let's go above. Option B is the correct answer. Problem 44. The neutral ion pi naught is produced in strong interactions, but it decays electromagnetically to 2 photons. However, the pion is not considered to be a strange particle because it forms an isotriplet with pi plus and pi minus, which are not strange particles. So option D is the correct answer. Problem 45. A certain op-amp has an open loop gain of 10 to the power 5 and a common mode gain of 0.2. The CMRR is, the common mode rejection ratio CMRR can be calculated using the following formula. CMRR is equal to 20 log that is base 10, and the argument is differential gain divided by the common mode gain. So in our case this is equal to 20 times log with base 10 to the power 5 divided by 0.2. If you calculate it, it's around 114 decibel. So option B is the correct answer. Problem 46. A sinusoidal voltage V input is equal to V sin omega t is applied to the input of the following circuit with RC equal to 0.1 second. We have to calculate the output voltage. The output voltage can be calculated as follows. So V output is equal to the impedance of the capacitance divided by the impedance of the capacitance plus the impedance of the resistance times V input. So this quantity we have to calculate. So let us calculate that. So ZC divided by ZC plus ZR is equal to, we know the ZC is 1 by J omega C. So we have this can be simplified to 1 divided by 1 plus J omega C R. Now this is equal to 1 minus J omega C R divided by 1 plus omega square C square R square. So we can write this quantity as in polar coordinate as a e to the power I phi. We need the phase factor here. The phase factor is equal to tan inverse of minus omega CR. Now we use the value of CR and this is equal to 1 by 10. So we found that phi, the angle, is equal to minus of tan inverse of omega by 10. Thus V output is equal to some quantity that is positive times I phi divided by V input, and the angle phi is minus of tan inverse of omega by 10. So thus we found that the output voltage lags behind the input voltage by this amount. Problem 47. A signal of frequency 20 kHz is being digitalized by an AD converter. A possible sampling time which can be used is, so according to Nyquist theorem, the sample rate could be at least twice the frequency, that is the rate should be 40 kHz. Now we have to convert this to seconds, and this is equal to 1 divided by 40 times 10 to the power 3 seconds. And now we convert it to microsecond, so multiply 10 to the power 3 both in numerator and denominator. So that is equal to 1000 divided by 40 microsecond, and this is 25 microsecond. So option A is the correct answer. Problem 48. The decimal equivalent of hexadecimal B2 F8 is. So in hexadecimal system, B is equivalent to 11 and F is equivalent to 15. So this B2 F8 is essentially 8 times 16 to the power 0 plus 15 times 16 to the power 1 plus 2 times 16 to the power 2 plus 11 times 16 to the power 3. And if you calculate this, this is 4, 5, 8, 1, 6. So option D is the correct answer. Problem 49. The following Boolean expression simplifies to. So we shall use the 2 De Morgan's theorem. So now let's simplify each of these parts. So from the first part, this is equal to A1 dot A4 bar using this, and in the second part this is equal to A2 bar dot A3, and from the third this is A3 dot A4 bar. Now this simplifies to A1 dot A2 bar dot A3 dot A4 bar. So option A is the correct answer. Problem 50. To obtain a first order diffraction peak for a crystalline solid with interplane distance equal to the wavelength of the incident X-ray radiation, the angle of the incidence with the normal should be, so the situation is like this: the X-ray beams are incident on the solid at this angle theta, and the condition for the Bragg diffraction is 2d sin theta is equal to n lambda. Since we are looking for the first order, n is equal to 1 and the interplane distance d is equal to the wavelength of the incident X-ray, the sin theta is equal to half, or theta is equal to 30 degree. So this angle is 30 degree. We need to calculate this angle alpha, and this is equal to 60 degree. So option D is the correct answer.